All right, now we want to move on to graphing nonlinear functions. Remember, before you even put anything here on the graphing grid, you need to make sure that you write down every single thing that you know about the graph. So in this one, we see that we have the absolute value symbols here, so we know what the shape is. When you see the absolute values, you know that you have a V shape. Now let's see what else we happen to know about this. Inside, we see a +2. But we remember that what's on the inside, we end up doing the opposite of that, and we move horizontally. So I see a +2, which means I actually go to the left 2 units. It has nothing to do with the absolute value part of the function. It's because it's inside the main part of the function. Right? So whether it's inside your square root, if it's inside your absolute value, your square, whatever it is, it's a horizontal shift opposite of what you see. And then outside of the absolute value, we see +5. And when it's outside, you do exactly what you see. And so that means we're going to go up 5 units. So right away, we can go ahead and shift to the left 2. So I'll have to go ahead and draw my new set of x and y axes like this. Go to the left 2, and then go up 5. And so here is your new origin. That's your new starting point. Okay. Now the rest of this is where we look to the front part right here. Okay. So with what we have here in front, here's what we know. Because of the negative, this means that we have a reflection. We reflect across the x-axis. Not only that, but because of the 3/5, that's a value that's less than 1. So we're going to have a vertical compression. Now, normally I would be kind of scared about seeing 3/5, but since this is connected to absolute value, and we know that absolute value is made up of straight pieces, right? It shouldn't be too difficult to put all of that together. In fact, we can use the negative 3/5 just like it's a slope. Okay? So first of all, we're going to, here we go, we're going to plot our vertex, which is right here. And by putting it right there, we've already taken care of the left 2 and up 5, so I don't need to worry about those anymore. The rest of it is graphing with the shape, absolute value, V shape, and this negative 3/5 compression. So from here, that means you're going to go down 3 and over 1, 2, 3, 4, 5. And do that again. So we'd go down 1, 2, 3, and over 5, like that. And you're also going to do it on the other side. You're going to go down 3 and 1, 2, 3, 4, 5 to the left. So now we just need to connect these guys. Remember with the V shape, it's made up of straight pieces, so there's no curving here. In fact, where'd it go? Well, I guess I'm just going to have to freehand this one. It's going to look just like that. Make sure that you don't do anything crazy on the ends. Make sure this guy does not curve at any, in any way. It's opening like this. It's going to be straight on both sides. There's no curve, especially when you get right here. For some reason, a lot of students want to try to curve at that vertex, but it doesn't happen. You're going to go up, and you're going to make a sharp turn and go down. Okay. Now, just for some extra stuff here, it's not really being asked of you, but so that we are all aware of this. If we want to know what the domain is, the domain is going to be all real numbers. We see as we go from the left to the right, there are no breaks, there are no gaps, so it includes all real numbers. Your range is as you go from bottom to top. What are the values that we're using? Well, we see this guy goes all the way down. There's no stopping that. But he maxes out right here at 5. So the range is coming from negative infinity and goes up to 5, and it includes that. Now, some other information that might be helpful to you is determining over what intervals is this function increasing or decreasing. So whenever you hear or read questions like that, talking about where are you increasing and where are you decreasing, Okay, this is where we're talking about where does it go if it's increasing, where is it going up, and decreasing, where is it going down. Okay, so if you look here in this picture, as you trace along with your finger from left to right, you're going up, and then you're going down. So you are increasing here, and you are decreasing here. Now when it says over what intervals are you increasing or decreasing, they're talking about open intervals, and they're talking about intervals of your domain. So we see that we're going up from negative infinity up to an x value, that's very important here, up to an x value here of negative 2. So when x is negative 2, that's when you stop increasing, and that's where you start to decrease. So you decrease starting when x equals negative 2 and going all the way to the right as x goes toward positive infinity. Understand here at negative 2 we're using parentheses, because when x equals negative 2, you are not going up and you're not going down because it's at the pinnacle. It's at the very top. So he's neither increasing nor is he decreasing. Okay? So when we talk about those intervals, they're always open intervals, parentheses on both sides. Now our next example is to graph f of x is equal to x minus 4 quantity squared minus 7. And when I see the square, this square tells me that I'm dealing with a parabola, which means you should already have in your mind what those key points are. Now, where has this guy moved? Well, let's see. I've got a minus 4 on the inside here, and a minus 4 on the inside. That's horizontal, opposite of what I see. So that means I'm going to go to the right 4 units. And then I've got the minus 7 out here. And remember, when it's outside of the function, it's a vertical shift, and you do exactly what you see. I see negative 7, so that means I'm going to go down 7 units. So it's at this point that we go ahead and we sketch out our new x and y axes. So we are shifting to the right 4, and we are shifting down 7. So you can just pretend that this right here is our new origin. And then you would count out. You mark this as this is your new 1, your new 2, 3, 4, and so on. And if, as long as we understand what the shape is and what the key points are, we shouldn't have any problem finishing the rest of this graph. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 1, 2, 3, 4, 3 squared is 9, so that's going to be up here. 4 squared is 16. That's actually going to fit here because this is going to be 7 plus 9 is 16 all the way up here. And you can copy these points on the other side because we do have this line of symmetry. And it's going to look like that. So it's all about understanding your key points. Knowing that this is 1 squared and that gets you 1. 2 squared is 4. 3 squared is 9, and 4 squared is 16. That's when I'm coming up with the numbers. And it's all being measured. Look how I've drawn this. It's all being measured from this new horizontal line that got shifted down 7 units from the original. And now we're going to take our pen and draw a nice, smooth, parabolic curve going through these points. Remember, down here it's a nice smooth curve. It does not very quickly change directions as we saw in the absolute value function. So there we go. Now, just like we did on the last problem, let's go ahead and talk about domain, range, and where we're increasing and decreasing. So this guy here has a domain of all real numbers. At this point, there are only 2 types of functions that have any kind of restrictions on their domain. That would be square roots, which we've seen, and then there are fractions, which we're going to be seeing in a little bit. So no fractions, no radicals, the domain should be all real numbers. The range. Range is as you go from bottom to top, so the lowest the graph gets is a y value of negative 7, and this guy goes all the way up to the top, no stopping, toward infinity. And now let's talk about what open intervals of our domain, are we increasing or decreasing? Remember, when we talk about increasing and decreasing, it's always as we move from left to right. So take your pen or pencil or finger, whatever it is, and trace along as you go from left to right. You start here, and you're going down as I move to the right, and I bottom out. And then as I keep going to the right, this guy starts to go up again. So you're going down, you're going up. You're decreasing, and then you're increasing. And so we want to talk about over what values of x, over what parts of our domain are we increasing. Well, you don't start increasing until you get right here. See what that is? That's an x value of 4. So you're increasing from 4 to infinity. And keep in mind that these are open intervals, just like we mentioned. But you're decreasing on the left half of this. So you're decreasing from negative infinity up to an x value of 4. Again, when we're talking about increasing and decreasing, we're talking about intervals of your domain. Okay, so you're decreasing from negative infinity to an x value of 4, and then you start to increase again just on the other side of 4, right here, from 4 to infinity. Again, as you go from left to right.